Simplify the following. A number expressed entirely as a radical is called an entire radical. As an example, the square root of 20. If given a radical in the form the nth root of a, the a in this case is called the radicand. The n is the index of the radical. If there is no index shown, it is assumed to be 2, corresponding to a square root. A number expressed as a rational number multiplied by a radical is called a mixed radical. As an example, 2 root 5. A radical in simplified form must be expressed as a mixed radical if possible. To do this, factor out the largest possible perfect square from the radicand, or perfect cube or power of 4, etc., depending on the index. Then take the square root of this factor, or cube root or fourth root, etc., to obtain an integer. The other factor is left inside the radical. Let's look at the first example, the square root of 56. We can write the square root of 56 as the square root of 4 times the square root of 14. We then write the square root of 4 as 2, giving us a result of 2 root 14. For question B, the square root of 128 s cubed. We can separate this as the square root of 64 s squared. Note that 64 and s squared are both perfect squares. The other factor left inside the radical is 2s. The square root of 64s squared is equal to 8s, giving us 8s root 2s as our final answer. For question C, we now have a cube root. In this case, we're looking for perfect cubes that are factors of 54. In this case, that's going to be 27. We break this up then into the cube root of 27 times the cube root of 2. The cube root of 27 is equal to 3. This gives us 3 times the cube root of 2 as our answer. For question D, again we have a cube root, so we're looking for a perfect cube factor of negative 56 t to the 5. This will correspond to negative 8 and t cubed. This leaves us inside the radical the cube root of 7t squared. The cube root of negative 8t cubed is simply negative 2t, giving us our result, negative 2t times the cube root of 7t squared.